In this next screencast, we are going to explore three related concepts, but each of which is separate. Position, displacement, and distance are all three central concepts to the subfield of physics called kinematics. Let's first discuss the space under which they operate. We will consider one-dimensional space, which is represented by a number line. Notice we have an origin or a reference point. This is a critical component of analyzing motion. We have positive numbers in this direction and negative numbers in this direction. So we have an origin and we have directions specified. What is shown on the number line is positions. Position is where something is located. It has a magnitude, let's say 3, and a direction, positive, +3. Similarly, it could have a position of -4. It would have a magnitude of 4 and a direction that is negative. Let us consider some examples where the position is changing. In this case, we have a position that starts out at -5, and the object is moving in this direction toward more positive numbers. Here we have a different object at 0 and moving toward more positive numbers. And here one at 3 moving toward more positive numbers. What we would say is that the change in position of all three of these is positive. The direction of change is positive. Now let us consider the opposite example. Here we have an object located at 3 moving toward more negative values. Here we have one at 0 moving toward more negative values. And here we have one negative moving toward more negative values. All of these indicate the direction of change, which is negative. The direction of change is independent of what the position is. An object can have any position and have either a positive or a negative change in position. Exploring position a little bit further, we have 3 dimensions as we learned about previously. Position is described by 3 coordinates, x, y, and z. And in physics, we treat each one separately. Position for all of these is where something is located. It does require an origin, and that origin we could also refer to as a universal reference point. On the number line, we can see 2 different objects, a purple one and a green one, each with a position. The position of the purple one is +4, and the position of the green one is -2. Notice we have a magnitude 4, a direction is positive. Here we have a magnitude 2, and the direction is negative. Displacement is related to position. Displacement is the change in position. The definition of displacement is change in position, and it is given by the variable delta x. D, capital, the Greek D, capital D, for delta or difference in x. The difference in anything is always the final condition minus the initial condition. So the displacement is equal to the final position minus the initial position. So let's consider the blue point up above, which would be this one. We have a final position of +1. We have initial position of -4. So our final is +1 minus a -4 means our change in position, our displacement, is +5 meters. Let's see if that rings true. 1, 2, 3, 4, 5. And the change is in the positive direction. So in this sense, displacement has a magnitude, 5, and a direction, which is positive. Let us consider the green example, where we have an initial position of 4 and a final position of -2. Now we can see just from the number line that it's going to be moving in this direction, so we would expect the displacement to be negative. So let us see. Final minus initial, the final is -2. the initial is 4, so minus 2, negative 2 minus 4 is negative 6 meters. In other words, the position changed by 6 in the negative direction, a magnitude of 6, a direction that is negative. That's the displacement. The object was displaced from here to here, negative 6 meters. And the final case we have here, and our blues and purples look very similar, involve these 2 points. So here's our final, and here's our initial. So we can see again, when we go from initial to final, we would expect a negative displacement from the picture. So we have final minus initial. The final is 2, and the initial is 5, which gives us a displacement, delta x, of minus 3. Magnitude 3, direction is negative. The third concept is the distance, and the distance is how far something is traveled. Now let's remember, position is where something is located, displacement is how much it has changed, and distance is how far something has traveled. So let's see here how this is different. We have an object starting here at an initial position of plus 4. We see it moves to this location, negative 1, and ends up at a position of 3. So we can see its position was 4, then its position was minus 1, then its final position, resting place, was 3. So those are the positions. The displacements, in this case here, the first displacement was negative 5, then it was positive 4. But the question is, what is the distance that this person or this object will have traveled? Well, we can see they moved 5 in this direction and 4 in this direction. So we would expect the distance to be 9 meters. That's how far it traveled. You can see that if we ended here, the distance would be 10, an additional 1 meter. But the displacement would be 0. It ended where it started. And the position would be the same. So if we were to calculate the displacement of this green case, we have final minus initial position. The final was positive 3. The initial was 4. So we have a change in position of negative 1. And let's see if that's true. We started here, and we ended up in a direction negative 1 unit. And that's true. In 2 dimensions, we treat each dimension x and y separately. So we can have an initial position over here given by the coordinates 5, 3. And the over positive 5x, positive 3y. And similarly, we have a final position of positive 2x, positive 7y. So we have an initial position here and a final position here. What we can see is the change. The change here, we went from, in going from XO to XF, in the direct X direction, we went from 5 to 2, a change of minus 3. So delta X is minus 3 meters. The magnitude is 3, but the direction is negative. And if we look at the Y increased from 3 to 7. So its displacement is positive 4. And of course, we recognize a 3, 4, 5 triangle. So interestingly enough, we would say that the distance along this path would be 5 meters. The displacement in the x is negative 3. The displacement in the y is positive 4. The distance traveled is 5. Now to recap, we discussed 3 different quantities: position, displacement, and distance. Both position and displacement can be positive or negative. That makes them something called vectors, where direction matters. Distance is different. It can only be positive, and quantities that can only be positive are referred to as scalars. Examples of scalars are distance and speed, and vectors, position, displacement, and velocity. Position could be positive or negative, displacement could be positive or negative, and velocity could be positive or negative. But distance and speed are only positive.